Hello bachcho, let's read the question. The question says that a parallel beam of white light is incident on a thin film of air of uniform thickness. Now, wavelength 7200 Armstrong and 5400 Armstrong are observed to be missing from the spectrum of reflected light viewed normally. The other wavelength in the visible region missing in the reflected spectrum is of how much Armstrong, right? So यहाँ पे क्या हो रहा है? Basically, there is a parallel beam of white light which is getting incident on a thin film of air, okay, which is of uniform thickness. Now, out of that, wavelengths of 7200 Armstrong and 5400 Armstrong are observed to be missing from the spectrum of the reflected light when viewed normally. So, the question is, the other wavelength in the visible region that is missing in the reflected spectrum is of how much Armstrong, okay? So, to understand this, let us first of all understand the diagram of the same. Okay? So, let's say this is the incident line, okay, and then this is the, let's say, reflected line, okay. Now let's assume that interference happens somewhere over here. So this is the point of interference, okay. So the point where reflected and the incident line meets, at that point interference occurs, and the wavelength that is missing is because of the destructive interference. Why is the wavelength missing? The wavelength is missing because of the destructive interference, okay. Now, so therefore, can we say that 2 mu t here, let's say this is mu and thickness is given to us as t, okay, for this. So can we say that 2 mu t equals to n lambda, right? And what is this 2 mu t? This is the apparent distance traveled by the light in this medium, right? So this is nothing but apparent distance traveled by the light in this medium, and n lambda is the new formula for the destructive interference, which becomes that, which is known as n lambda, okay. So now if we solve it further, can we say that 2 mu t is equal to n lambda 1, that is for the first wavelength, equals to n plus 1 lambda 2, that is for the second wavelength, which is again equal to n plus 2 lambda 3, right? So therefore n into 7200, that is the first wavelength, is equal to n plus 1 into what is the second wavelength, that is 5400 Armstrong, right? So if you solve this out, you will get the value of n as 3, okay. So now next wavelength, that is the third wavelength that is missing, it must also satisfy this condition. Which condition? This one, right? So can we say that n lambda 1 is equal to n plus 2 lambda 3, right? So n lambda 1 is equal to, lambda 1 का value we know, n का value is 3, the 3 plus 2 is 5, lambda 3 is what we are supposed to calculate. So if you solve this up further, you will get the value of lambda 3 as 4320 Armstrong, okay. So now if you look at the options, option number B, that is 4320 angstrom, is our final answer. So I hope you all understood the concept. All the best.